8.2, testing a claim about a proportion. Remember, when we talk about a proportion, we're talking about that P. That's the parameter for the population. So we're talking about this proportion P, and as soon as we see that, we know we're talking about the normal distribution. We've got some requirements, but we've got this test statistic. This is a z-value. It's like the number of standard deviations, where p hat is talking about the sample, and p is talking about the population. We're going to have several different ways of doing what we're doing. We're doing hypothesis testing, and we're testing claims about proportions. There's this confidence interval method, which is probably not going to be preferred. It says this method is not equivalent to the p-value and critical value methods, which could result in a different conclusion. We're going to like the p-value method probably the best, followed by the critical value, and then we'll throw some confidence interval in there as well. But down here it says, remember, our recommendation, use a confidence interval to estimate a population proportion. That's what we did last chapter. We estimated the population proportion. We put it between two numbers and said we're 95% confident that the actual value is in between these two. We want to use the p-value method or the critical value method for testing a claim about a proportion, and that's what this chapter is about. So we start off with an example here, example 0A, uncomfortable with drones, p-value method. Survey asked 1,009 consumers if they're comfortable having drones deliver their purchases, and 54%, or 545, said no. Use these results to test the claim that most consumers are uncomfortable with drone deliveries. Now, there's a requirement check, and you're not going to want to do it, but basically we're supposed to check the requirements each time. And requirement number 1 is it's got to be a random sample. And it is. And requirement number 2 is it has to be a binomial distribution. And what that means is there's a fixed number of independent trials with 2 categories. And yes, that is, looks like there's 1,009 trials, and your 2 choices are they're either uncomfortable or they're not. Your third requirement is n times p has to be greater than or equal 5. N times q also has to be greater than or equal 5. Well, n is 1,009, and p was, well, the claim is that most consumers are uncomfortable with drone deliveries. So we're going to say that's greater than 0.5 when we talk about most. So 1,009 times 0.5 is definitely bigger than 5, and likewise NQ is going to be the same thing in this case, because if the probability of something happening is 0.5, then the probability that it doesn't happen is also 0.5. Both of those check out. So those are your requirements. You're probably going to skip over that when we get into the problems, but just know that we're supposed to be checking the requirements. So we're using those results to test the claim that most consumers are uncomfortable with drone deliveries. Now, last lesson in 8.1, we did some basics of hypothesis testing, and we went through 8 steps for hypothesis testing. Step 1 was just come up with your original claim. And if we're talking about most consumers are uncomfortable, you might see the word majority, but we're going to say P greater than 0.5, more than half. Step 2, give me like the opposite of that. What's true when that's not true? Well, the opposite of that is less than or equal 0.5. Step 3 is where you start talking about the null hypothesis. And the null hypothesis, H sub 0, is just you look at whichever one of those 2 things, and the one that has equality, we're just going to say, okay, we're going to say P. I wish I hadn't done an equal sign there. P equals 0.5. The alternative hypothesis, H1, is going to be the statement that doesn't have the equal sign in it. P greater than 0.5. This one is our null hypothesis. This one is our alternative hypothesis. And that's what we're going to test. Step 4. Talks about the significance level, and if it doesn't give it to us, we're going to choose alpha equals 0.05. That's just a common number, and if it doesn't give it, that's probably what we're going to choose. Step 5 says, what kind of distribution is this? And so since we're talking about proportion, P, we know that is a normal distribution. All of this feels like setup for what we're trying to get to. We haven't really done anything good yet. Step 6 is where we have to actually do some kind of math. Step 6, we want to find that test statistic. And since this is a proportion, and we know that's a normal distribution, I think I had it up here in this chart, your test statistic is a z-value. Z equals those numbers. After I show you how to do this with the technology, you won't need to do this by hand, but I want to show it to you by hand first of all. P hat minus P over square root PQ over N. P hat is that proportion number for the sample. That's the numbers that we measured, and that would be this right here. Your P hat is going to be 0.54. This is P hat. Your P number is the population number, more than, most consumers. We're talking about greater than 0.5, so we're definitely talking about 0.5. That's what we're testing. Over the square root of P is your probability, and so again, the probability is 0.5, and the opposite probability is 0.5. N in this case is 1009. So you type that in on your calculator, make sure you use parentheses appropriately. You're going to get about 2.54. And that's an important number because that's going to tell us something. All right, so essentially, as soon as we knew this was greater than, as soon as we see this symbol right here, we know it's going to be right-tailed. We've got the same normal distribution picture that we've seen a lot of times, but we know we're talking about a right-tailed picture. And this picture has two numbers attached to it. There's this z value, and this p value is the area under the curve. Well, we just found the z value. We found the z value was 2.54. Step 6 is, we just did step 6. Step 7 is find that p-value. Now again, once I show you how to do it on technology, it's going to give you all these numbers anyway. But we don't need it because we've done this in previous chapters. To find that p-value, we know that we can just do a normal CDF on our calculator from that 2.54 number to infinity, or in our case, we usually just type in some big number like 9,999 or whatever. And since it's a standard normal distribution, it's got a mean of 0 and a standard deviation of 1. That p-value, let's see. I know this is really small. I can't even get it to work. Well, never mind then. Found the p-value was 0.0055. The z-value of 2.54 corresponds to the area under the curve of 0.0055. And what we're supposed to notice out of that, there's this saying, if the p is low, the null must go. So you might want to remember that. If p is low, the null must go. Because remember, when we're talking about the p-value, we're comparing it to alpha. We're going to compare the p-value and say, is the p-value less than or equal to alpha? Well, our p-value is really low. It's 0.0055, and our alpha, remember, we chose was 0.05. We see how that p-value is less than or equal to the alpha value. That tells us something, okay? That tells us if the p is low, the null must go. That tells us to reject the null hypothesis. We're rejecting the null hypothesis. Okay? And that's going to lead us to step 8, which is our conclusion. Now, if you flip back a couple of pages to section 8.1, step 8 says restate the decision using simple and non-technical terms. I didn't spend a lot of time on this in 8.1 because it didn't make sense without an example. But basically, you've got to figure out which of these 4 things we're talking about. And so look at the original claim does not include equality, and you reject the null. Well, we definitely rejected the null, right? So it's one of the 2 that I just checked right there. But think about the original claim. The original claim does not include equality, and that was this. This was the original claim, right? This was the original claim. It does not include equality, and so we're talking about this one and not this one. So your conclusion is going to be language that looks like this. There is sufficient evidence to support the claim that, and then whatever the original claim was. So that's how you have to write your answer. There's sufficient evidence to support the claim that. Let's see if I have enough room for that. There is sufficient evidence to support the claim that, what were we talking about? Most consumers are uncomfortable with drone deliveries. That's what this original claim was in real words. Most consumers are uncomfortable with drone deliveries. All right, now that problem took forever, but it doesn't have to once we figure out how to use the technology. So let me see if I can actually go to my keyboard and make that calculator work. So those of you with the TI, okay. If you've got a TI, again, sorry this is so small. You can move closer if it's too small. But you need to go to the stat, hit the stat button, and then you're going to arrow over to tests. And so since we're talking about a proportion, we've only got one of them, we're doing a one prop for proportion z-test. One proportion z-test. And you have to enter in the numbers. P0, that first number was 0.5. X, they gave it to us, was 545. That just so happens to be 54% of 1009. N was 1009. And then you have to choose whether it was equal or not equal, less than, greater than. And since this problem was greater than, we're going to pick greater than, and we're going to calculate. So notice they give you a z-value, and this rounds off to 2.55, so we're a little bit off when we did it by hand, but it's close enough that who cares. That's our z-value. We can see a p-value. Wait a minute. I think I hit something wrong, because see how that p-value is not right? Let's go back. Oh, for some reason I'm still on equals. Got to be on the greater than. There we go. Yeah, I picked the wrong one. It's got to be greater than 0.5. I think I had selected not equals. So we can see the z-value. We can see the p-value of 0.0054. So again, we're kind of off, but it's still close enough that we can still see if the p is low, the null must go, right? This is lower than our alpha, so we didn't really have to do a lot of this stuff. We wouldn't have had to do this step 6 calculation. We wouldn't have had to do this step 7 calculation because it just gave it to me right there, 0.0054 or whatever. So that's very useful. Oh yeah. If you don't have a TI, then look at how you do that on StatDisk. If you go to StatDisk, you got to go to analysis up here, hypothesis testing, proportion 1 sample, and it's basically the same thing. We're going to select greater than. The significance level here was 0.05. That was the thing that we chose. The claimed proportion was 0.5. Sample size was 1009, and the number of successes, I believe, was 545. There we've got the same thing. Z is 2.55. Your p-value is this. It's very low. If the p is low, the null must go. Now that we've done one by hand, hopefully they'll speed up a little bit. Example 0b is the exact same thing, but this time it says the critical value method. The critical value method. So the critical value method, let's see. I guess it's easier looking at StatDisk because StatDisk gives me that critical that critical value right there. So remember what we're talking about when we see that it's talking about most consumers, and we know that it's greater than 0.5, and we know that this picture is right-tailed. The critical value method says there's some critical value, and we want to see if our numbers are more extreme than that critical value. So since this is right-tailed, we want to see if it's to the right of that critical value. So normally what we would do, well, I guess if you didn't have this telling you it was 1.64, what we would do is inverse normal, and you'd say, okay, well, this is if we said alpha was 0.05, then this is 0.95 over here, and this is 0.05 over here. We would say we want to find this critical value. We know the area to the left is 0.95, that's 0, that's 1. We've done this all before. To get that critical value was 1.64. That critical value right there is 1.64. So we chose alpha to be 0.05. That was this area right here. So we can use our inverse normal to find that critical value. This value is 1.64. Oops. And that value corresponds to this area, 0.05. But using our technology, we can see that the test statistic is 2.55. 2.55 is over here. Now, on up above, we found the area that corresponded to 2.54, or in this 2.55. We found this area was tiny, right? And so we said if that value was low, the null must go. But using the critical value, we don't really need to look at that area. We look at this value. And since this value puts us in this critical region, it's basically the same exact conclusion. So steps 1 through 6 are the same as above. Step 7 instead of doing the p-value method, we're doing the critical value method. And we say our z number equals 2.54 or 55, depending. 2.55 is in the critical region. And so that's telling us, remember early in the semester we talked about being significantly high, okay, or rare. That's telling us the same thing. So this tells us to reject the null. If that critical value puts us in the, or if that z value, that test statistic, puts us in the critical region, then we know to reject the null. And our step 8, the conclusion is the same thing as before. So step 8, copy this down. Step 8, there is sufficient evidence to support the claim that most consumers are uncomfortable with drone deliveries. Same conclusion, of course. We just did a different method. We looked at the critical value instead of the p-value. We looked at the z value instead of the area under the curve. Okay. Can I move on? Example 0C says, let's do the same thing, but let's do the confidence interval method. Now your confidence interval, we did that last chapter, and we did it a lot last chapter. And for a proportion, the confidence interval, we said p hat minus e is less than p is less than p hat plus e. And we had to find this e using this formula z alpha over 2 times the square root of pq over n. And that was fine. And we did all of that. We already did that in this chapter. And we could go through and do that again by hand. But StatDisk is kind of cool because it gives you the confidence interval. Okay, we've got this 0.51 is less than p is less than 0.57 or so if I round off. And so think about your claim. Your claim is that most consumers are uncomfortable with drone deliveries. So we're thinking that value of p is going to be greater than 0.5. Well, look at it. This sure suggests to me that p is going to be greater than 0.5, right? I mean, if the true value of p is in between 0.51 and 0.57, then yeah, that suggests that we're greater than 0.5, right? And so we can say something like we have this confidence level that the true value is in between there, and so we're guessing, yeah, okay. So guess what? The answer is the same as it was in 0A. There is sufficient evidence to support the claim that most consumers are uncomfortable with drone deliveries. Do we need to write that again? Yuck. Now remember, confidence interval method isn't quite as good as the other two. We don't like it as much. It doesn't lead to the same results all the time, just sometimes. So we'd rather do the other methods. Example 1, finding the number of successes. A study of sleepwalking was described in Neurology magazine, and it included information that 29.2% of 19,136 American adults have sleepwalked. What is the actual number of adults who have sleepwalked? This is not nearly as tricky as it might sound. That 29.2 is your p hat. That's the sample proportion, and your n is 19,136. Literally all we're going to do is multiply or find 29% of that number. You get about 5,587.7. But we're talking about the number of people. You're going to have to round off to a whole number. So we're going to say 5588 right there. And you'll need that number sometimes if they don't give you that number to plug it into your calculator. If you're going to use technology, remember when we needed that number of successes X, We needed that number, not a p hat value. We don't want to type in 29.2%. We need an actual number. So that's what that's going to be used for. So here's number 2. Okay, we've got those same pieces of information. Would a reporter be justified in stating that fewer than 30% of adults have sleepwalked? Let's use it. Oh, here's a typo. I don't want to use 0.005. Get rid of one of those zeros. Let's just use a 0.05 significance level to test the claim that for the adult population, the proportion of those who have sleepwalked is less than 0.3. So again, you're supposed to test the requirements. Is it random? Yup. Is this binomial? Yup. NP, NQ, those are both bigger than 5, greater than or equal 5. So the requirements check out. Step 1, in this case, fewer than 30%, so less than 0.3. Okay, less than 0.3. Step 2, the opposite of that, greater than or equal 3. Step 3, when we talk about the null is the equals. And the alternative is the one that does not have equals. I keep saying H equals. That's not how you write it. H. P equals 3. And the alternative, P less than 0.3. Step 4, they told us alpha was 0.05. Step 5, since we're talking about P, we know we're talking about a normal distribution. All this stuff is set up, and all this stuff should happen pretty quickly. Okay, so step 6, we want to find that test statistic. And you've got several different ways of doing it. I gave you a formula, Z equals P hat minus P over square root of P Q over N. You can do it that way, or you can use your technology. I'm going to use StatDisk, I think. So this time it was less than. Significance still 0.05. Claimed proportion 0.3. Sample size was 19,136. And the number of successes, that's that number we got from that last problem. The number of successes was 5,588. Okay. So our test statistic right here, negative 2.41. Negative 2.41. That should match. That should match what you got if you did it on your calculator, or if you did it by hand, I suppose. So let's picture what this looks like. When we see that less than symbol, we know that this picture is left-tailed. And our Z number that we just found was negative 2.41. That's not the same thing as the critical value. That's our test statistic. And so we need to find the area, but the area that goes with is the p-value. P-value is right here, 0.008, I guess, 0.008. So that's, I think the p-value method is a little easier than the critical value method. Because all you have to do is remember, if the p is low, the null must go, right? And so we're comparing that number right there, p-value less than or equal alpha, question mark. Or in this case, 0.05. 0.008 is less than or equal 0.05. Okay, good. That tells me to reject the null hypothesis. Incidentally, maybe this line is actually way over here, because like your critical value, whatever it is, I don't know, corresponds to an area of 0.05. And so the area that we just found is this tiny little sliver, and it's less than that area that corresponds to the critical value of 0.05. So again, if the p is low, the null must go. And again, you have to think about this, okay? And it's going to be hard. You got to go back and look at this. The original claim does not include equality. Yeah, right. And you reject the null. Okay, so it's the same language this time. It's the same exact language. There is sufficient evidence to support the claim that it will not always be this language. It might be this one or this one or this one. And you got to look back at this chart and you got to think about this. There's sufficient evidence to support the claim that, that's step 8. What were we claiming? Fewer than 30% of adults have sleepwalked. The exact method for testing claims about a population proportion, we're going to, instead of using an approximation, we're going to do the binomial distribution itself. We can find these exact results using that binomial distribution. Now, in this method, we still have a couple of the requirements. It has to be a random sample and it has to be binomial, of course, if we use a binomial distribution, but we don't need these two anymore. And so maybe that makes it easier, maybe that makes it harder, I don't know. So we're going to identify n and x and p, and we're going to use this box depending on what kind of test it is. Find the p-value using technology for finding binomial probabilities as follows. So we've got kind of 3 different things to check depending on what kind of tail it has. Let's look at number 3. In testing a method of gender selection, 10 randomly selected couples are treated with the method, each having a baby, 9 of which are girls. Use a 0.05 significance level to test the claim that with this method, the probability of a baby being a girl is greater than 0.75%. So we can see that's N and that's X. And over here, that's your P number. We can say P is greater than 0.75. But as soon as we see that greater than, we know this thing is right-tailed. And if it's right-tailed, then we know we're going to use this formula. So start with that. The p-value equals the probability of 9 or more. Well, 9 or more, there are only 10 people, so that's going to be the probability of exactly 9 or the probability of exactly 10. And here's where our binomial formula comes in. Think way back to when we did these. The probability of exactly 9 out of 10, we're going to say 10 choose 9 times 0.75 to the 9th times 0.25 to the 1st. Since it's an OR, we're going to add together the other result. This result, out of the 10, we're going to choose 10. All 10 of those will be the 0.75s, and that means 0 would be the 0.25. Those are your binomials. That's binomial probability, and that's going to be your p-value. So we calculate that, and you're going to trust me on this one, but once I type that in, I get about 0.2440. That's your p-value. Remember what we said. If the p is low, the null must go, right? We are comparing the p-value to alpha. And since we can see that is not, in fact, less than or equal to 0.05, then we know we're going to fail to reject the null. Fail to reject the null. So we fail to reject the null, and the original statement did not include equality. Look at this chart. We fail to reject the null, and it does not include equality. That means this is going to be our conclusion. There's not sufficient evidence to support the claim that. There's not sufficient evidence to support the claim the claim was that this method gets the probability of a girl greater than 0.75. There's not sufficient evidence to support the claim that this method increases the probability of a girl greater than 0.75. In a study of the accuracy of fast food drive-through orders, one restaurant had 34 orders that were not accurate among 369 orders observed. Use a 0.05 significance level to test the claim that the rate of inaccurate orders is equal to 10%. Equal to 10%. Does the accuracy rate appear to be acceptable? So part A says identify the null and alternative hypothesis. Well, step one, you got just what they're talking about. Step two says give me the opposite of that. Well, the opposite of that is not equal. And so step three, you've got the null. Step three, your null hypothesis is just the one that has the equals in it. And your alternative hypothesis is the one that does not have the equals in it. Compute the test statistic. Well, let's do that using technology again. So you can use your TI or you can use StatDisk. This time it's equal. This was 0.1. Sample size in this case was 369, and they gave me the number of successes was 34. You guys can head out if you want to, but I'm going to finish this video. You want the test statistic right here. It looks like the test statistic is negative 0.50323. Oops, where is it? Z equals negative 0.50323. Find the p-value. Well, we've already got it. The p-value is going to be this 0.6148. So that's really high, right? 0.6148. That's your p-value. If the p is low, the null must go. Notice it's pretty obvious to see that that's not less than or equal your alpha, or 0.05. Okay. So state the conclusion. Well, what have we got? Well, that's pretty obvious that we're going to fail to reject, right? We are going to fail to reject the null hypothesis. By the way, we didn't have to draw it, but this one is two-tailed. We haven't seen very many that were two-tailed here. If it's an equals, it's going to be two tails. And so your test statistic tells me to look to the left of this, wherever it is. But anyway, we can tell from the p-value that we're going to fail to reject this. So think about the conclusion. You got to go to this box again. So we're going to fail to reject, and the original claim includes equality. So the language looks like this one. There is not sufficient evidence to warrant rejection of the claim. So that's what we have to say. There is not sufficient evidence to warrant rejection of the claim. What was the claim? That the rate of inaccurate orders is 10%.